Hello everyone, in this video I'd like to share an update on my bare minimum Go playing program that I made recently, maybe half a year ago. I don't quite remember when exactly. So, this is the program to play the game of Go. For those who might be confused with the name, it's not about Go programming language, it's about the game of Go. And I've been making a tutorial series on how to write your very own program to play Go in Python. That was the remake of the Go playing program of 80s called Wally. There was a pseudocode for that program in the Byte magazine by Jonathan K. Millen, who has created a Go playing program to run on unexpensive Kim 1, believe it or not, with only 1K of RAM. So there was quite a tiny design there. So I've reused that design. There was a pseudocode also explain how things are essentially working. And when it comes to implementing the rules of the game, it works perfectly well. Well, apart from not having the rule of co being implemented in that original program. So later, I tried adding co rule, but the first time I made it was all just wrong. It didn't allow me to do snapbacks. So in order to be capable of doing snapbacks, I needed to fix some issues within the code. Still, I have some issues within the code, and those are listed in the known issues section in the README file of the project. But most likely, if you don't know those tiny little details about the rule of code, you would most likely not encounter that. Although that is still something that can be added into the to-do list. Anyway, this is not the most important stuff here. The most important stuff is heuristics. So the original program by Jonathan K. Millen was searching only one ply depth, and what was the problem there? So it tried to capture the group if possible. It tried to extend liberties if the group is in a tarry, and it tried to surround opponent stones if it has nothing else to do. And also, I guess it was trying to make some random moves and also trying to apply some patterns. But the problem with this approach was that when many groups arise on board, it gets messy and it's not really clear like the priorities. And when you start dealing with those priorities, generally it just starts playing very poorly, so it's not going anywhere. So I decided to when I wanted to make a JavaScript version that I can play online, like in the web browser on any device, I thought that maybe I can try to use the Nigamax search. Nigamax search usually not used for the game of Go because of the insane branching factor, but I messed it up even more. So usually Nigamax search is only used to search for forcing moves, in example for fighting moves, when you're about to capture opponent's group or dealing with life and death problems, or when you're trying to save your group, whatever. But I was thinking like how to give an engine an idea of how to gain some territory, and I created a function to calculate the territory that is occupied by a given site, so that maybe this would be a good idea, good heuristics. But all that did not work. I ended up with having an extremely slow engine, only two plies depth search, and on 19 by 19 board, it took ages to make a single move. So it wasn't going anywhere. And in that state, this program was stuck for a long time. So recently, I managed to make a big leap towards making it so playable. So how the heuristics works at the moment, I'll obviously demonstrate this how this works. But before that, I just want to mention all these things I consider to be really important. So now the heuristics works as following. Now engine has no idea about the objective of the game, that it needs to get territory. But if human player plays weird moves, he would lose because engine would eventually take more territory than human player. So how on earth is that possible, you might be wondering. So that's how it's working. So first of all, in order to make search deeper, so to make it a more reasonable fighting, I ended up with four play search, four play depth search, and that's much better than two play depth. Yeah, and usually that's enough. Well, it's not enough for sure, but it's much better than two plies. And now the search only calculates forcing moves. Forcing moves are those liberties to be filled if the group has less than three liberties. So, say you have a group with two liberties, then engine would try to either kill or save that kind of group, and it will only be calculating those moves recursively if it's about the group that has less than three liberties. If the group has more than two liberties, or there is no group that has less than three liberties, or if group has less than three liberties but it's dead, so it's not reasonable to calculate moves for it. In this case, it would try to tenuki. And the only Tanuki move I came up with, Tanuki means play away, that's the Go term. So the only reasonable Tanuki I came up with, I tried many different ones, but the only reasonable Tanuki is to attach to opponent's stones, to user stones in particular. So you just imagine the following: if black player plays reasonable moves, it surrounds territories, and white tries to attach, so territory gets split. If human player, if user is making a small group in the corner or on the side, engine would try to surround it. And let's say human made one single group in the corner, and engine surrounded it. So black lives, but white essentially took the whole board. The program made the way so that if no empty squares left on board, it means that the game is over. Although in the real game, you can still try to invade opponent's territory, even if no empty squares are available, no territory that doesn't belong to anyone. I mean, but you may think of this as a handicap to the computer because it's really weak. So this is how it's working. It's not doing like pass and another side passes and then the game is over. That's too complicated, yeah. Although a computer can pass if it doesn't know what to do, it's more likely due to, I don't want to call it bugs, but maybe bug is a good word. But anyway, passing behavior sometimes might get weird, and this is another part of the known issues. But anyway, generally, what is very interesting that it's kind of playable on 9 by 9, on 13 by 13, and on even on 19 by 19 board. And one last but not least thing, that before starting to attach everywhere, by the way, attach allows to block if you're trying to invade, if you're trying to reduce opponent's territory, it may start blocking. So attach is very universal kind of move, turns out to be. And in the opening, it would try to take four corners if available. It would try to take four sides if available, and then it would just start attaching. And with this simple heuristics, believe it or not, if human plays poorly, and if human would blunder a group in Atari, it would get instantly captured. So in this case, engine really has chances to win. So I will now demonstrate how I can play on all these three board sizes, and I will demonstrate both like letting engine win, so not playing strong moves, because I really want you to see how it can operate when it just doesn't doesn't know very much anything, but still. But then I will probably show you how it can play itself. Versus itself is also quite interesting, and yeah, so how to play with white, and how it plays itself. Those are related questions. And how to give an engine a handicap. We can also have a look at that if I don't forget about it. So simply just filling the board array with the fixed value that represents the black stone. then drawing the board, and you start from the position where you have like as if opponent played a few moves already, just like in a regular handicap. Okay, let's go and let's see what we can do. By default, it loads to 13 by 13 board, but let's kickstart with 9 by 9, right? So I will start with doing very, very weird moves, just to give you an idea how I can lose the game, because yeah, the fact that this program can win is amazing to me. So I will just try to make a living group in the corner, and I make 2 eyes here, okay, and maybe I make another eye. So by the time it took all the 4 corners, it took all the 4 sides, okay. It doesn't look that great on 9 by 9 board. It looks much better on bigger boards, but anyway, he has a grip on the center. He sort of has some grips on the corners. Essentially, this should be a 1 game for whites. Now the next move, he starts attaching here. So I just try to play something. Well, this is a losing move, because if I play here, and I just capture, but he cannot see that far, so I just give him a chance. Okay, so he keeps attaching here. And okay, so this is the way to sort of save the stone. It's not going to work, but this move comes from the recursive search. Okay, and now he finally sees that there might be a problem with this stone, and it saves the stone, which is great. So another attach, so blocking black, so it's not going anywhere. Now I just play very weird moves just to give an idea. So he would be attaching to my stones. So I just take away my very own eye. So the very last eye I can take is this one. So before this, I will probably take this. Yeah. And now the next move, well, I can obviously try to make a living group and even kill this entire thing here. That is possible, trust me. But I don't want to do this. So if I want to save the game, if I see that there is only white territory and only black territory, so if I want to end the game, I just fill 1 more liberty, and it gives me the final score. So the final score, white wins by 48.5 points, which is reasonable because like all the entire board is taken by white. So this is how you can lose the program, right? Now I can show you how you can win against the program. So I can start with 3-3, and probably, okay, so if he can take corner, he would take. If he can take the side, he would take. So this, and this are the points that where he can take the side. So let's invade. Okay, he takes another corner. Let's invade here as well. Okay, now go in here. Well, I can be very brutal and kill him, but yeah, I would still be giving him a chance. I would win the game, but I would still be giving him a chance. He only has 1 eye here, so obviously I could try to kill this, and most likely that would work, but I just want to give him a chance. So like this, and maybe, okay, so sometimes it throws away stones because of attachments. Yeah, by the way, if I take, it also takes, so this is good. Okay, now he blocks his very own. Okay, very good thing here. Okay, and Hana, well, this is not good. Okay, I expect him to block, but yeah, this is the weird kind of behavior that he tries to literally put stones in. So I want to take this one, take this one, and after I take this, so I should be. By the way, it's not obviously it doesn't obviously mean that I win the game. Yeah, still white wins by 1.5 points. Believe it or not. So this throw-in thing that he does, essentially is just attaching, but he doesn't know that he is attaching in opponent's territory. But with this weird strategy, he essentially won by 1.5 points, which is interesting, yeah? So yeah, I thought I would win this game, but essentially I lost the game. Okay, now let's I will play my full playing strength, and I will just smash it and probably kill everything eventually. So I just try to kill everything now. Okay, cut, and here, and I'm trying to kill this group. He's thinking now because, yeah, he understands that this group is in trouble. Okay, if I wasn't careful, he could have captured my stone. Okay, no mercy this time, so blocking this one. So I'm going to capture this group. Okay, he passes because, well, essentially doesn't know what to do. Well, position feels quite lost, but we can keep playing. It passes. I want to make it so that there are no territory that does not belong to anyone. Okay, and here we go. Yeah, sometimes he moves in a weird way, but on the other hand, yeah, I also take this. Okay, now the pass. I'm about to kill this one. Okay. Okay, and kill this one. So now black is much better, as you can see. Okay, he keeps passing, and I just kill, and after I kill this, it tells me black wins by 41.5 points. And obviously, you may wonder that I could also take this. I could also play here next move. So essentially, yeah, but it's game over. So if I didn't take this stone, if I try to kill this, then I would have grabbed everything. So just to give you an idea that essentially, if you know how to play Go, this program is very weak. It's not a real opponent. But anyway, let's go and play on 13 by 13 board. This time, let's play as white player. So I want to say play, opening developer tools, play depth 4. Essentially, any depth can be done because it's a nuke anyway, because there are no falsy moves. And now, yeah, let's play. So I'm playing my Kamoko points here. All right, he takes the sizes. Looks on a bigger board. What he does looks reasonable. Okay. All right, so I dare to invade. Okay, by the time he takes the site, so he's doing quite good. Okay, yeah, and here, takes here. Okay, and go in here. He starts grabbing some central points, which is good for him. So, black only 3, but black is going to gain more. Yeah, again, not playing most severe moves because I really want to give it a chance. I always want to give it a chance. You see, like it starts kind of yeah, developing the center. Even though he knows nothing about territory, this is so cool. He knows nothing about territory, yet he is trying to capture. There's a whole lot of points, and he connects to form a territory, but he doesn't know about this. It just attaches. It's just all it knows is just how to attach. Nothing much but to attach. Yeah, this works, interestingly. Okay, now I put him into long thinking. Okay. So yeah, I hope it's not going to crush. Yeah, sometimes it makes moves that are not going anywhere, but yeah, anyway. So this way, I block here, takes here. Now he's passing. Okay, and after I capture this, no, the game is not going to be over yet. But anyway, so black is now winning. Yeah, now at the moment, black is winning. Can you believe? Yeah, so here, and after I take this, black is going to win the game. If I take here, black is going to win the game, yeah? I don't want that to happen, really. So I just invade the corner, and I play more, and I play here. Okay. Is this dangerous? Not yet. So he knows nothing about 2 eyes for sure. That's the reason why you can kind of do all this weird looking things. This should be dead. He could have killed this if he knew how to, but he doesn't, so I have a chance. Okay, put him into a lawn thinking again, which is interesting. Obviously, I did not. Okay, I think it's about to crash. Oh no, it didn't crash. Cool. Um, so, is it going to find this move? Yeah, let's see if he is going to find this move. Still white is better. You see, still white is better. Okay. Yeah, just try to play. Yeah, he finds the move. Can you believe? Can you believe he finds the move and he kills me there? Okay. He finds the move and he kills me. Okay. White is worse. Yeah, black is still, it's not very good. Yeah, obviously I can try to win anyway. If it's not going to crush, okay, it's passing here. Okay, let's finish this. Is this essentially it? Well, this should be defended, but yeah. Yeah, black wins by 35 points. Okay, I give him this game. So we have the sections here, the data section, containing all the variables that are used for this program to work. The GUI section, all functions regarding the look of the program, to draw the board, to handle the user input, territory, score, and an update score. These are the functions to print how much territories white has, black has, and empty as well. Then the engine part itself, so initializing the board, empty, the board set up the off-board squares. They are not seen, but they're used for handling captures on the board edges and in the corners. Eninge, this is done to check if computer is about to play a suicide move. So to avoid suicide moves, this is done here. Clear block clears erases the stones when they are captured. Captures is the function to handle capturing the stones. Yeah. Count is one of the core functions, one of the very essential functions. It's used in counting territories, it's used in counting liberties, it's used in figuring out whether the group is in a tarry. So it's the very the mostly used function in the entire source code. Restore board removes the markers, because when we count liberties, values of black and white stones are getting adjusted, so we need to adjust them back and also clear the data structures holding blocks. This is the group to be erased if you captured liberties. Those liberties that particular group has, and the points regarding to the given site. Set stone is a routine to place the stone on board. Also, it checks the legality. So, if you can put the stone, or if you cannot put the stone. Get urgent moves is very interesting. It finds the groups that only have one or two liberties, and it returns those liberties, those squares, as a list, so that later within the search, so evaluate just counts the difference between white and black stones. That's how we know that who has more stones is better, because if you have more stones, this means that you have captured opponent's stones, since the number of moves is similar. So if I have 10 stones, my opponent has 5 stones. It means 10 minus 5 equals to 5. It means that I've captured 5 stones, my opponent. Okay, so search. So we only loop over the urgent moves here, not over all of the moves available, but only over the urgent moves. All right. So if we encounter an off-board square, then we just continue not looking at this. If the urgent move is a co, we are not looking into this. Okay. And then we just preserve the board state, try to make a move if it's possible. Okay, if it's not possible to make a move, we just continue. Then we recursively search depth -1 until we hit the depth 0, then we return evaluate. And the eninge max itself, so if we found if evaluation is better than the best score, which starts with -10,000 and -infinity, then best score becomes eval, and best move gets associated with the best score. So restoring board state and restoring co returns the best score. Tanuki is play away when no urgent moves. So these are the points to set up stones in the corners. These are points to set up stones on sides, and this works relatively to 9x9, 13x13, and 19x19 boards. So first we try to set up the stone in the corner if possible. If it's not possible, trying to set up the stone on the side. If neither possible, assuming that still there is the territory that does not belong to anyone. Only in this case, we try to attach a stone to the opponent's group. But a bunch of conditions here, so make sure that we're not attaching on the first, second, and third lines. Although it still may attach there, but it's complicated to explain why, because of the offsets are not always going from the right direction. So anyway, like attaching to opponent stones, to user stones essentially. In Atari is meant to find the biggest group that can be captured on board. So this is used for computer when before searching moves, it first tries to find if there is a big group to capture, and if he finds one, it just does capture that group. That's it. And play. So the function that is called every time user clicks on the board placing a stone. So first try to find the biggest group that is in Atari. Okay, and if it happens that it's available and it's not a co, then best move would be the best quick, essentially capture. Okay. Um, so, and in this case, we should play the move. I'm not sure where the set stone is done. Yeah, this is it here. Try to set a stone. Right. Otherwise, if we don't have best move here, okay. Otherwise, we need to recursively search, and in case if search results are bad, that we don't play the best move. Instead, we tanuki. So this might be eval less than 0 might be no forcing move. We would go here. And there are some forcing moves, but Saito play is going to lose anyway. So we'll also get here. So in this case, we want to tanuki. Tanuki play away. Either playing the square, playing the side, or attaching. Right? And so try to set the stone. Okay. If it doesn't, then try to try again. And up to 10 attempts. Okay. So every time we make another attempt, we change the side, update the score. Make sure that empty like territory that does not belong to anyone. If it's equal to 0, this means that the game is over. So no territories that does not belong to anyone. This is the game over condition for this particular implementation. Then we just do black score minus white score, final score, and that would be the difference. Okay. And otherwise, if still there are points to play, to take, then engine would simply pass. Shuffle is used to randomize attachments when tenuki happens. Just not loop over from square 0 to square, like the biggest one available on board, but traversing those squares in random order. So this shuffle makes the random order possible. Print position is just a debugging function. So when it was like debugging the count routine, capture routine, see the mock squares, how they work, if the board gets restored or not. So print position was quite helpful back then. Finally, the main part, we attach user input function as the on-click event, as the callback function for the on-click event listener, right? And we also detach this when the game is over. So here we detach when the game is over, so you cannot click anymore. And this allows to change the board size when you're using the drop-down menu. Finally, when the program starts, we first initialize the board and then draw the board. And that's essentially it, guys. So, yeah, many questions to this project, really. But what I'm really proud of is that, unlikely its previous state, now it's self-playable. And that's a big achievement. But yeah, to say that this is finished, or if this would ever be finished, this is very hard to say because the code is messy. I hate the code when I look at it, because I wasn't really thinking about code much. I was more thinking about the functionality, and I try to keep the implementation simple, small. So it's only 357 lines of code for the entire program to work. Yeah, so let me know in the commentaries what do you think about this program, guys. And thank you for watching this video. This is from my side, and I'll see you in the next one. Until then, and cheers.